The second side of the lean construction triangle is the operating system. We will take a brief look at three of the primary methods that the majority of lean projects use. These are target value design, pull planning and scheduling, and building information modeling, or BIM. Of course, there are many more methods and tools than these. Nevertheless, these are foundational for the other methods to build upon. Lean is not about efficiently building an inefficient design. The greatest opportunity to influence the delivery of value for the lowest cost takes place in design. The objective of target value design is to develop an efficient design by factoring cost directly up front as a design criteria and not waiting until after design to determine costs, which would then trigger inefficient value engineering sessions. Designing to a detailed estimate and not estimating to a detailed design requires total team collaboration and is nearly impossible to do outside an IPD environment. Typically, designers, in absence of trade participation, will design with the worst quality installers in mind to protect themselves. This results in costly, over-designed facilities. When trades who are to install the work are involved in the design process, the waste of building more than what is needed is significantly reduced. Also, the waste typically incurred from the redesign effort to produce shop drawings that take place when trades are onboarded after design, which can be as much as 15% of the cost, is avoided. Target value design maximizes value by exploring good, better, best choices in sets of options rather than sticking to one option too early, which typically results in a back-to-the-drawing-board effort and a loss of schedule. Having the ability to make decisions at the right time, which lean champions call the last responsible moment, on the right set of options reduces redesign and schedule delays. Co-location in a big room for large projects and the use of technology to enable collaboration is essential to achieve the short turnaround times necessary for timely decision-making. In an IPD environment, design cluster leaders include cost as an element of design and weigh those good, better, best options together to optimize the overall design within the project budget. The overarching rule is the target cost or budget cannot be exceeded. The benefits to target value design are reduced rework late in design and minimal value engineering or cost amputation exercises that strip value out of the project. Again, real value is not the low bid on a high-cost design, it is the low true cost on the right design. Building Information Modeling, or BIM, is an enabling platform for collaborative design. Like the old saying goes, measure once, cut twice. Measure twice, cut once. BIM allows the team to build the facility virtually first by making measurement adjustments before actually executing the design with bricks and sticks. All the system clashes and interferences are detected and corrected to improve field productivity and greatly reduce field changes and change orders. A mature BIM approach includes the elements of time, cost, and parametric data for the total life cycle management of the facility. The additional benefits of BIM include designing for increased off-site fabrication, early end-user approvals, early agency reviews, better field coordination for just-in-time delivery, pre-planning for scaffolding and crane locations, and work sequencing, just to name a few. Here's an example where BIM facilitated the prefabrication of piping spools and clevis attachments in a coordinated structural steel infrastructure. What was interesting to note is that no chop saws were on the job. The one instance where one was brought on site was because of a little dimensional creep on one of the long pipe runs. Also, the amount of high work was greatly reduced, which made for increased safety on the job. Another method for increasing field productivity is through pull planning. Traditionally, work schedules are pushed out to the trades by the superintendent or master scheduler. However, because in more cases than not, and for various reasons, the trades are unable to meet this schedule. In other cases, excessive float is built into the schedule as a contingency, which artificially pushes out the schedule longer than needed. In still worse cases, trade stacking is incurred when no allowances are built in. Yet in all cases, no master scheduler has the capability of coordinating all the complex interactions of all the trades. For traditional jobs, it is not uncommon for 50% of the superintendent's time to be spent chasing down trades to do the work instead of truly planning work. The traditional approach can be likened to driving in rush hour traffic. One moment you're speeding up, and the next you're slamming on the brakes because the person ahead of you is doing the same. This stop-and-go driving is hard on the car. It is also hard on projects. The concept of pull is not that unfamiliar to us. Grocery stores operate on a pull basis by restocking shelves only as needed, not by a master scheduler. On construction projects, we already use a pull-like approach on time-sensitive activities such as pouring concrete. We only bring the mud to the job when the forms are set. Pushing the loaded trucks to the site any sooner would result in an expensive waste of unused material and a lot of extra work to chip out the drums. The lean approach using the last planner system involves the trades in the planning effort, with the end result being more reliable schedules. Workflow is smoothed out by having those who are doing the work collaborate together to develop schedules in milestone pull planning sessions and weekly work planning sessions. The picture to the side shows a typical pull planning session, usually done with post-its on the wall, where foremen make commitments to one another on what can be done. Constant crew size balance is worked out with the other trade crews to allow work to flow through the building, minimizing the starts and stops of work. Contingency floats are reduced significantly, which results in an overall shortening of the total project duration, while achieving high productivity and cost control. These pictures are an example of the innovation that can result from collaborative pull scheduling. The excavation foreman came up with the idea of lowering the entire grade when discussing the plan for trenching with the other trades. The hauling and sand backfilling costs were a little bit more, but the saving from eliminating shoring, trenching, and faster utility installations more than offset these costs. This was a case of where spending more in one area produced multiplied savings for the entire project. The ability to be innovative like this and move money across contracts was made possible with an IPD supporting contract and accounting systems. In summary of the operating system side of the lean triangle, cost goes from estimating to a detailed design to developing a design to meet the target cost. This removes the wastes of overdesign and value engineering rework. Designing what can be built using BIM reduces the wasteful practice of redesign in shop drawings, which can be as much as 15% of the trade staffing cost. Scheduling is pulled from those doing the work to balance crew loads and shorten durations rather than pushing schedules from the top down. Hence, commitments become more reliable by participants, which reduces float and buried contingencies. Control of the project is no longer a matter of keeping score on what has already happened, but in team members working collaboratively to plan how work gets done, with the net results being optimized for the entire project as each participant puts the interests of the team first, knowing that when the tide of project productivity rises, all the boats will float. The question from the owner's point of view is, if we have the right team, using the right methods, will I see financial benefit? To answer that question, we need to look at the final leg of the lean triangle, commercial terms. The contract, in essence, codifies the project culture and influences the behavior of the project team members. So how is contracting different in lean construction? Traditional contracts mainly deal with compensation, deliverables, and risk to structure project relationships something like this. This can create distance between team members. The relationship between designer and constructor is not always clear and results in silos and parochial behavior. Strain can develop between parties because traditional contracts are geared towards the self-interest of each party and are risk-averse in language. This can trigger adversarial working relationships and finger-pointing when things go wrong instead of the collaborative joint problem-solving behavior needed for innovative solutions. How often do project team members come together as strangers and leave as enemies? Ask anyone who has signed a prenuptial agreement if you want to understand how a contract can influence behavior. Lean contracts take a different approach by bringing the team together and are often called relational contracts since they focus on the organization structure, the project operating methods, and commercial terms that facilitate the sharing of savings. One of the main objectives is to get the issue of money out of the way in order to release collaboration, innovation, and productivity. To do that requires trust. Trust is foundational to Lean. If you don't trust a supplier to handle your money, you should look for another supplier. Mistrust costs. It fosters divisive thinking that tears apart the unity of the team and stifles innovation. The sickness in many projects is a sickness of division, and it often is codified in contracts that separate and divide rather than unite. Lean contracts facilitate shared savings, one that incentivizes lean behavior by the supplier and netting a lower overall cost for the owner. Contracts need not be divisive. My own experience in Japan is that when there is a high trust, we can get a lot done using two-page contracts. Risk must be considered when selecting the type of contract to use. The questions are, how much risk should each party carry? And who pays for it? It is indeed a balancing act of risk versus benefit. It is also reasonable to expect, as in any business enterprise, that whoever takes the most risk stands to gain the most benefit. So let's look at the spectrum of contract types in view of risk and savings, though we will not touch on every possible derivative. At one end of the spectrum is the lump sum contract. The owner transfers the bulk of the risk to the supplier. This typically results in a higher price since contingency is baked into the contracted value. A lean approach on a lump sum contract would give the contractor all the innovation and productivity savings. The owner may benefit from a faster schedule and better quality. However, part of the owner's objective for lean is to realize the savings. The question here is, what is the owner's financial incentive to make the timely decisions and to truly collaborate and innovate with the supplier? At the other end of the spectrum is the time and material cost plus contract. The owner carries the bulk of the risk and therefore would be entitled to all the savings. The downside is there is little financial incentive for the supplier to collaborate, innovate, and drive productivity other than having a good track record that may help win the next job. In the middle is the shared savings contract. The risk and reward is shared between the owner and the supplier. The contract can take several forms ranging from the full integrated form of agreement, or IFOA, to design-build with the team sharing a common IPD team contingency for design and construction errors and other unexpected costs that would not result in a change order. IPD team members place their profit in an at-risk pool. If the project overruns the agreed-upon target cost, then cost overruns are funded from the at-risk pool first, then by the owner. The owner limits liability of risk pool members to the at-risk pool. Aggregate project savings are typically put into the pool. Risk pool members agree on a plan for funding, administrating, and dispersing the at-risk pool and any aggregate cost savings and profit amounts. A relational IPD agreement would normally provide mechanisms for the owner and project team to collectively share those risks and protect the project team from catastrophic cost overruns. The upside is that the benefits from collaboration, innovation, and productivity improvements are significant and far outweigh the risk exposure. The important objective of the contract is to support lean behavior and provide a means for realizing the financial savings. To maximize the benefits of a lean approach, a procurement strategy needs to support three elements of a project team development. Early onboarding of all major participants, including trade detailers and design, to maximize innovation. It seems counterintuitive to early onboard trades because we as the owner may feel we are giving up our ability to negotiate a good price. However, experience has shown that the pennies we think we save in competitive bidding after construction docs are released is more than lost through the dollars of redesign and change orders as the trades gain clarity as to what can be built. Seamless integration of architects, engineers, construction management, major suppliers, and trade detailers to reduce change orders and rework that typically results from groups working in silos. Shared savings for Amgen partners. To realize the cost benefits of lean, incentives are to be contracted to stimulate innovation beginning early in design when there's the greatest opportunity for influence without incurring major change orders. Setting up an incentive pool with key project partners is one way to accomplish this. Then we must be confident that we are hiring trusted partners and then trust them. The importance of learning can be illustrated by a story. Once upon a time, a very strong young man asked a timber merchant for a job as a woodcutter, and he got it. The pay was really good, and so was the work condition. For those reasons, the young man was determined to do his best. His boss gave him an axe and showed him the area where he was supposed to work. The first day, he chopped down 18 trees. "Congratulations," the boss said. "You're doing great. Keep it up." Very motivated by the boss's words, the rookie woodcutter tried harder the next day, but he could only bring in 15 trees. The third day he tried even harder, but he could only bring down 10 trees. Day after day he was bringing less and less trees. "I must be losing my strength," he thought. He went to the boss and apologized, saying that he could not understand what was going on. "When was the last time you sharpened your axe?" the boss asked. "Sharpen? I had no time to sharpen my axe. I've been too busy trying to cut down trees." Learning is a sharpen the axe activity. It requires periodically stopping to evaluate the team's lean effectiveness. This can be accomplished by as little as meeting for 1 hour every 2 weeks as a team to specifically address improvement. Also, taking time to visit other successful lean projects outside the company can help stimulate ideas for removing waste and improving the way work is being done. Another way to learn is by attending local Lean Construction Institute meetings to learn what others are doing to advance lean on their projects. Question: what do Phil Mickelson, the Los Angeles Lakers, and the Green Bay Packers have in common? Besides being champions at one time, they all have coaches. Phil has Butch Harmon. The Lakers had Phil Jackson and 5 assistants during their championship run. The Packers had Mike McCarthy and had 20 assistants when they won their Super Bowl in 2011. Good teams have good coaches. Project teams are no different. Coaching can come from inside subject matter experts or from outside consultation. Typically, project managers are too wrapped up in the project to step back objectively to serve as a facilitator or coach on their projects. Therefore, PMs should work with their site director and with the engineering project delivery team to identify coaches and facilitators. In summary of the commercial terms side of the triangle, the lean and integrated project delivery approach to contracts is different. The focus on team chemistry becomes just as important as the agreed upon deliverables. Suppliers are recognized as trusted partners and not interchangeable commodities. Contracts support the sharing of risk and reward. Project accounting allows the movement of money to optimize innovation. The language, including the phrases we associate with contracts such as having teeth and being ironclad, are replaced by words such as trust and collaboration. All the above is made possible by selecting trusted partners on a best value basis instead of a low bid. The golden rule always applies to contracts. He who has the gold makes the rules. The role of the owner is to lead the openness through relational contracts so that project partners will respond in kind. Lean must be approached holistically. Attempting to execute a lean project without considering all aspects of the triangle will fall short of realizing all the benefits hoped for. When all three sides of the triangle are addressed together, like what we observed on industry-leading lean projects, the results will be lower cost, better schedules, better quality, and an improved project team environment. However, there is one final thought. This is a picture I found on the wall at one of the large pioneering lean projects. The project leadership realized that to get extraordinary results, a new mindset was needed. This picture served as a daily reminder to think and act differently. The lean journey takes commitment to change and to challenge the status quo. It involves trust and collaboration with our partners to innovate and improve our project delivery processes. It requires an investment into learning and openness to new ideas. It calls for patience and persistence to realize sustainable and lasting results. For more information about lean construction, please visit the Lean Construction Institute website.